What would happen if you set foot on a planet where the ground simply doesn't exist? It seems impossible to imagine a place where there is nowhere to escape, where there is no way to gain a foothold, where falling is the only certainty. Jupiter is like that. A planet so gigantic that it could swallow more than 1,000 Earths, but which holds in its essence something even more frightening than its size. It has no defined limits. Instead of soil, it has layers and layers of dense gases, pressed so violently that they defy any logic of human survival. Imagine being there. You wouldn't touch the ground. You wouldn't feel firm. You would be swallowed inside. The fall would never end. And with every kilometer, your body would face a new level of pressure, heat, and chaos. And the most disturbing, no one knows for sure what exists in the core of that planet. What's down there may be much more than we imagine, something that defies even the known laws of physics. In this video, you will understand why Jupiter is much more than a gaseous planet. It is a true cosmic nightmare, a place where everything we know as life, science, and stability falls apart in a matter of seconds. But don't expect to find easy answers. What's coming are extreme scenarios, surprising scientific hypotheses and discoveries that could change the way you see the universe. Comment below. If you had the chance to go down to the heart of Jupiter, knowing that you might never return, would you accept that risk just to discover what no one has ever seen? Comment below. How far would you go to unravel a mystery that could change everything we know about the universe? I want to see how far your theory goes. And keep watching, because what you'll discover in this video could completely change everything you thought you knew about the largest planet in the solar system. Some scientists believe that hidden forces on Jupiter may be revealing a pattern that we haven't yet been able to decipher. And when they do, it may be too late. If you tried to land on Jupiter, you would face an immediate and definitive problem. There is no place to land. Unlike Earth, Mars, or even the Moon, Jupiter does not have a solid surface. What human eyes and telescopes see as clouds are actually a deep, complex sequence of layers of gas, mainly hydrogen and helium, that become increasingly denser as you penetrate the atmosphere. It's like observing an ocean of compressed gases, where density and pressure increase exponentially with each kilometer descended. The idea of walking, standing on your feet, or even standing inside Jupiter simply does not apply. There is no soil, there is no base, and there is no way to stabilize anything within this environment. This lack of a solid surface was one of the great challenges faced by NASA's Galileo mission, which was sent precisely to study the planet up close. In 1995, the probe entered the Jovian atmosphere and transmitted data for 58 minutes before being completely destroyed. She did not collide with a structure, it didn't hit rocks, she was literally consumed by atmospheric pressures. The increase in temperature, density, and gravitational acceleration was so intense that the instruments could not resist. The data collected by this mission is still studied today because it indicates that Jupiter's atmosphere itself is a dynamic, active system and highly hostile to any known technology. Even if it were possible to create a pressure-resistant suit or a heat-resistant capsule, the simple fact that there is no physical structure to stop at creates a basic impasse. Jupiter's gravity is more than 2.5 times that of Earth. This means that any object, including you, would be pulled with extreme force towards the center of the planet, passing through increasingly dense layers of gas and being subjected to physical forces that no human biological structure could withstand. Instead of landing, you would begin a prolonged fall, where your speed increases and the environment becomes, by the second, more inhospitable, and there would be no escape. This concept is fundamental to understanding why Jupiter remains, to this day, one of the greatest challenges in space exploration. It's not just about distance, radiation, or size. This is the very structure of the planet, which breaks with the logic of everything we know about geography, surface physics, and limits of matter. It's the kind of place that wasn't made to welcome. It just exists and destroys everything that tries to get too close. But this dynamic hides a consequence that few people know about. The fall does not end with the pressure. There is a point where the gases transform into something that science is still trying to understand. Within Jupiter's atmosphere, there is a variable that eliminates any possibility of survival before radiation or temperature even come into play: pressure. As you went deeper into the planet's layers, atmospheric pressure would increase violently and continuously. To give you an idea, the pressure at sea level on Earth is approximately 1 atmosphere. On Jupiter, this number doubles within a few kilometers and continues to grow without interruption. At around 150 kilometers below the upper clouds, it would already exceed 100 atmospheres, the equivalent of the pressure that exists at a depth of 1,000 meters in the Earth's ocean. By now, any human structure, physical or technological, would have completely collapsed. The human body was not designed to withstand this type of environment. Even pressure suits or heavy-duty capsules would be useless after a certain point. Biological tissues, air cavities, and internal liquids would be progressively crushed until the organism completely lost its integrity. The closest comparison would be with an aluminum can being compressed by a hydraulic press, only much faster and with a much more severe intensity. The nervous system would not have time to react. The destruction would be practically immediate, starting with internal damage caused by pressure imbalance, followed by organ rupture, cellular collapse, and total structural destruction. This process would not require hours. It would only take a few minutes of continuous falling, perhaps even less, depending on the exact density of the region penetrated, for the body to be completely disfigured. And the scariest thing is that all of this would happen in the upper levels of the atmosphere. In other words, long before reaching the deepest layers, where extreme heat, electrical flows, and turbulent currents would make the existence of any structure even more unfeasible. The pressure on Jupiter is an invisible but brutal force that turns any attempt at penetration into a sentence of destruction. Science is still studying how far this pressure can build up before the hydrogen transforms into a metallic state, something that only occurs under extreme conditions of density and temperature. But even without reaching that depth, the effects would be more than lethal. The resistance of known materials on Earth would not be sufficient. Even advanced metal alloys used in space probes would have difficulty withstanding the physical stress generated by this environment. But if you still think that's the worst, wait until you understand what the winds do down there. Because unlike pressure, Jupiter's winds don't just crush, they tear, twist, and spread chaos in all directions. What is most intriguing about this scenario is realizing how much we still depend on hypotheses. Even with all the technology available, much of what we know about Jupiter is still deduced from fragmented data. And it is precisely in this space, between the known and the unknown, that the most important questions arise. Those that really move science forward. Leaving a like here is more than a way of interacting. It is a clear demonstration that you value content that challenges the obvious, that opens up new perspectives, and that treats knowledge as a constantly expanding process. It's also a direct way to strengthen a community that believes that exploring the universe is, above all, questioning the very limits of reality. And the more this type of content circulates, the more people start to ask the right questions. Now imagine the impact of winds so intense that they could easily destroy metal structures. Atmospheric currents swirling with an energy no terrestrial planet has ever produced. There is something about these winds that goes beyond speed, and that could be interfering with much more than just imagination. Defended. Amid the turbulent layers of Jupiter's atmosphere, there is a phenomenon that surpasses all known parameters of duration, intensity, and resistance: the Great Red Spot. First observed in the 17th century, this gigantic storm has lasted at least 350 years. possibly longer. It is so big that it could easily swallow the entire Earth and still have room left. Its winds reach speeds of more than 600 kilometers per hour, forming a constant whirlpool that challenges the limits of meteorology as we know it. On any planet with a solid surface, a storm of this size would have dissipated long ago. But on Jupiter, the absence of relief and the planet's gaseous composition create an environment where these cyclonic structures can remain active for centuries. This longevity isn't just impressive, it's enigmatic. There is still no definitive explanation for why this storm is so stable. The energy that keeps it active is believed to come from Jupiter's own interior, which emits more heat than it receives from the Sun. This internal heat creates convective flows and movement patterns that power massive atmospheric systems like the Great Red Spot. Furthermore, Jupiter's extremely rapid rotation, completing one rotation in less than 10 hours, intensifies the zonal jets, creating bands of winds that isolate the storm and prevent its dissipation. The result is a virtually self-sustaining cycle of constant turbulence. For comparison purposes, the most devastating hurricanes on Earth reach winds of around 300 km/h and usually last for days. On Jupiter, the winds are twice as fast and last more than 3 centuries. Getting into a storm like this wouldn't just mean facing strong winds. It would be like penetrating the center of an uncontrolled atmospheric turbine, where shear forces, rotation, and density would make any physical stability impossible. Equipment would be torn to pieces, metal structures would be twisted like paper. No current technology could cross this formation without being destroyed. And most disturbingly, this storm shows no signs of weakening. On the contrary, it fluctuates in size and color, as if it were constantly adapting. Scientists have already detected changes in the shade and shape of the spot, which suggests a complex internal dynamic which is still poorly understood. It is possible that there are internal layers of this storm with characteristics that we cannot even simulate here on Earth. What we observe from afar may be just the visible surface of an even deeper and more active system. We are scared by hurricanes on Earth. Imagine living in one that never ends. But the real question is, what is this storm revealing about the inner workings of the planet? Because perhaps what's happening inside the Great Red Spot is connected to a much larger dynamic, something that influences more than Jupiter's own climate. What we observe of the Great Red Spot may be just the surface of a much deeper system. Perhaps this storm is not an isolated phenomenon, but the visible manifestation of something that is acting at the planet's core, or even beyond it. What if these formations were the result of interactions that we can't even conceive of yet? What if Jupiter was channeling some kind of energy that we are completely unaware of? It makes me wonder how many other strange hypotheses are still beyond our reach, or perhaps hidden within our own imaginations. Now I want to hear from you. What crazy, unlikely, or totally mysterious theory about the universe has crossed your mind? That idea that seems too absurd to say, but that deep down you feel like it might make some sense. Comment your most intriguing hypothesis below. The most creative ideas could inspire future videos here on the channel. Is your theory the next question that no one has had the courage to explore? In addition to pressure, winds, and the absence of a solid surface, there is another factor that makes Jupiter absolutely inhospitable: its magnetic field. And when we talk about this, we are not referring to something similar to what protects the Earth. Jupiter's magnetosphere is the largest and most powerful in the solar system, estimated to be up to 20,000 times more intense than Earth's. It stretches for millions of kilometers, even encompassing some of its moons. It is a shield of colossal strength, but unlike Earth's magnetic field, which protects life, Jupiter's represents a direct and lethal risk. This magnetic force generates radiation belts so powerful that they make any safe approach for long periods impossible. Charged particles are trapped in these regions and form true electromagnetic bombardment fields. In practical terms, direct exposure would be equivalent to crossing a radiation zone thousands of times more lethal than that recorded in Chernobyl. Levels like this would be enough to destroy any electronic system in seconds and cause almost instantaneous biological failure. During the Juno mission, NASA needed to adopt a specific orbital strategy to avoid the most dangerous regions of this belt. The probe was designed with a special shield called a titanium vault, just to protect its central systems against radiation. Even so, its operational lifespan is limited. This shows us that no matter how advanced our technology is, we are still dealing with environments that exceed the limits of what we can support or monitor on an ongoing basis. What about a human body? There is no discussion. Direct exposure to Jupiter's radiation field would cause severe cellular damage in fractions of a second. DNA would be fragmented, proteins would be destabilized, and the nervous and cardiovascular systems would fail in tandem. Even highly reinforced spacesuits would have no chance of significant protection. The problem here is not visible, it is not physical, but it acts with devastating precision. This extreme radiation is a direct consequence of the planet's own internal dynamics. Jupiter rotates quickly, has a dense and probably liquid core formed by metallic hydrogen, which generates powerful electrical currents. These currents power a magnetic dynamo that creates an unstable, unpredictable field constantly powered by interactions with the surrounding plasma. It's like a natural reactor in constant activity without any control system. And unlike winds or pressure, this threat does not require extreme proximity. It can hit anything within reach of its invisible network of destruction. But if you were still alive up until now, the next stage is where the impossible happens, the invisible core. A point of speculation where matter behaves in ways that we do not yet understand, and where science begins to lose its certainties. When trying to understand what exists at the center of Jupiter, science enters a zone of almost absolute uncertainty. Unlike Earth, which has a solid core surrounded by defined layers, Jupiter has an interior so massive and compressed that it defies traditional classifications. The most recent evidence suggests that its core is not a well-defined structure, but rather a broad, diffuse region, composed in part of metallic hydrogen, a state of matter that does not occur naturally on the surface of any planet in the solar system. This type of hydrogen can only form under pressures and temperatures so high that the atoms lose their original characteristics. What was once a light gas, under extreme conditions behaves like a metal, conducting electricity and responding to magnetic fields. But it doesn't behave exactly like a liquid, nor like a solid. It is a substance in an intermediate state, unstable and still poorly understood. It is as if we are facing a material that belongs to a parallel periodic table where the known rules no longer work. The most accepted hypothesis indicates that this nucleus may be mixed with heavier elements in an amorphous and chaotic structure without clear boundaries. The transition between the center and the outermost layers is gradual and confusing. This means that, even with advanced probes, it is impossible to pinpoint a precise boundary where the nucleus begins or ends. And most importantly, simulations that try to reproduce this environment often present unexpected behaviors, which suggest that the laws of physics we know may not be sufficient to explain what happens there. The instability of this core is so complex that some models propose that it could expand or partially dissolve into the rest of the planet over billions of years. This would indicate an internal dynamic that is much more active than previously imagined, with exchanges of heat, matter, and energy occurring in a way that has not yet been quantified. The existence of this metallic nucleus in an exotic state is one of the reasons why Jupiter still intrigues astrophysicists so much. It may contain clues about the formation of gaseous planets, about the extreme processes that occur in other star systems, and even about the origin of the solar system itself. This type of knowledge is still restricted to a minority. Most people have never heard of metallic hydrogen, much less that an entire planet can hide a state of matter that science is still trying to decipher. You are part of a group that seeks to understand what is beyond easy explanations, and this already puts you on another level of curiosity. So share this video with those who are also like this. Send it now to that friend who loves to question the universe, because this conversation needs to get out of the bubble and reach those who are ready to think differently. Do you believe that the universe can hide forms of matter that science cannot even explain yet? Because if Jupiter's core already defies our understanding, perhaps it is just one example among many of a reality that we are not yet prepared to understand. And this idea leads us to a new kind of challenge, one that is not just physical, but also psychological. So far, we have talked about the physical forces that would destroy any human organism on Jupiter, but there is an aspect that is often overlooked when we think about extreme environments: the psychological impact. Even before the body gives in to pressure, radiation, or heat, the human brain would already be facing stimuli so incompatible with earthly experience that mental disorientation would be total. The thermal sensation, for example, would be absolutely incoherent. You would experience a brutal combination of extreme heat with a total absence of visible light. In an environment where infrared predominates, the heat radiated by the inner layers would reach your body, but your eyes would see practically nothing. The perception would be of being burned in the dark. The absence of sound is also an important factor. Unlike what is seen in films, there is no effective noise propagation in an environment with dense gases, which are rarefied in some regions and chaotically turbulent in others. The sound would distort, get lost, or simply not reach you. This would cause a complete break in sensory expectations. The brain, accustomed to processing stimuli based on visual, tactile, and auditory associations, would collapse when it did not receive coherent responses. It's the kind of situation where the very notion of time can be lost. The feeling would be that of floating in a space without reference, without floor, without light, without noise, where all that exists is uncertainty. This experience would activate deep instincts of panic, but without any possibility of reaction. In an environment like this, the notion of body dissolves. You wouldn't feel where it starts or ends, as the spatial reference would have been destroyed. The intense gravitational force, combined with the absence of fixed points and chaotic stimuli, would create sensory overload. The mind would no longer have parameters to interpret what is happening. Anxiety would no longer be just an emotional reaction and would transform into cognitive failure. Have you ever had that feeling of falling into the void when sleeping? Imagine that, only real and eternal. This basic anguish, which many know as a common psychological reflex, is just a faint glimpse of what the mental breakdown would be like for someone facing Jupiter's internal environment. What if we are underestimating the impact of this type of environment? Perhaps the true limit of space exploration lies not in what human bodies can handle, but in what our minds can handle. Despite being one of the most hostile environments in the solar system, Jupiter remains one of the most desired celestial bodies in science. Not because of its colonization potential, obviously, but because of what it represents in terms of origin, structure, and gravitational influence. Studying Jupiter is like investigating an ancient archive of the solar system, a living record of how everything formed billions of years ago. Its composition, dominated by hydrogen and helium, is similar to that of the Sun. This makes Jupiter a kind of failed star, whose mass was insufficient to initiate nuclear fusion, but whose structure bears the same primordial signatures as the original solar nebula. Missions such as Juno, launched by NASA, have been dedicated to observing Jupiter indirectly, using remote sensors and instruments to understand its magnetic field, internal structure, and atmospheric dynamics. Since landing is impossible, the only way to study it is by orbiting it and making extremely precise measurements. Even so, the planet poses ongoing challenges. The Juno probe's orbit itself had to be designed to minimize the time of exposure to radiation, highlighting how Jupiter is still, in some ways, an unexplored frontier. But interest in Jupiter goes beyond its composition. Its gravitational field exerts a fundamental influence on the balance of the solar system. It acts as a kind of cosmic filter, attracting or deflecting objects that could reach the inner planets, including Earth. Without Jupiter, the frequency of catastrophic impacts on our planet would be much greater. For this reason, some astronomers informally call it the bodyguard of the solar system. At the same time, its presence shapes the orbits of asteroids, comets, and even other moons, making it a dynamic regulator of orbital stability. Even though it is a planet that destroys any attempt at getting closer, Jupiter remains a key to understanding phenomena that go beyond its own size. It allows you to test models of planetary formation, understand processes of extreme magnetism, and simulate the behavior of gaseous exoplanets in other stellar systems. Jupiter represents a kind of natural laboratory, dangerous, inaccessible, but incredibly valuable. But what does this teach us about the universe itself and about ourselves? Perhaps the real lesson is not only in what we discovered, but in why we continue trying to understand what, at first glance, seems impossible to decipher. Jupiter is a constant reminder that the universe is not meant to be kind. As much as it fascinates us with its grandeur, its beauty, and its mysteries, it also shows us that the cosmos has no obligation to be welcoming. The largest planet in the solar system is both a scientific jewel and a death trap, a force that protects but also destroys. And perhaps it is precisely this contrast that makes it so mesmerizing. To explore Jupiter, even if only through simulations, is to confront the reality that many worlds out there were not designed to support life as we know it. They exist for other reasons. They carry memories of the formation of the solar system, clues about extreme phenomena, and challenges that are still beyond our reach. And yet, we keep turning our eyes to him. Because, deep down, understanding Jupiter is trying to understand the universe itself, in all its complexity, violence, and invisible order. Would you have the courage to approach a planet that could destroy you just by existing? Comment here. Would you set foot on Jupiter? And if you enjoyed this journey through the impossible, share it with those who love the mysteries of the universe as much as you do. Being part of this is more than watching videos. It's being involved in an ongoing journey through ideas that challenge everything we know. Here, each question opens the door to more questions, and you may be closer than you think to an answer no one expected. So subscribe to the channel and activate the bell. There's so much more coming, and you won't want to miss out. And since you've come this far, your mind is ready for what comes next. Now click on the video that is appearing on your screen. It will take you to another level of questioning, and perhaps to a new layer of the unknown.